Let us see how to compare fractions through some examples, right? Comparing means we'll be given two quantities and then we have to say which is larger and which is smaller. For example, we are given two fractions, 3 by 8 and 5 by 8. We need to identify which is greater and which is smaller, right? Or are they equal? Now, when we are given two fractions, there can be some possibilities. The first possibility is the fractions can be like fraction. The other possibility is it may not be like, right? The fractions may not be like fractions, they are unlike fractions. When the fractions are like, it is very easy to compare, right? Because the number of denominator or the denominator is the same for both cases. What we do, we just compare the numerator, right? So the fraction that has larger numerator is larger. This is what the rule says. So since the denominators are the same, we compare the numerators. So the fraction with greater numerator will be greater. Why does this happen? So if you look at 3 by 8 in this figure, so you'll see 3 out of 8 parts are shaded. If you look at 5 by 8, it means 5 out of 8 parts are shaded. So the number of parts are equal in this case, both the cases. Right? However, the shaded fraction is larger here because we are shading 5 out of 8 and here we are shading 3 out of 8. Now imagine this scenario, you have a pizza. The first scenario, you divide it into 8 parts and then you had 3 slices. In the second case or scenario, you divide it into 8 parts and then you have 5 slices. So in which case you had more quantity. It is 5 by 8, right? Now let us move to a different case. Right, this is a case wherein the fractions are not like, which means they don't have the same denominator, right? How do we compare such cases or how do we compare such fractions? First of all, we have to convert them to like fraction. How do we convert them to like fraction? We have to find a common denominator. We already know how to compute the LCM of two numbers, right? So we find the common denominator through LCM. So we'll write these two numbers 4 and 8. So 2 2s are 4 and 2 4s are 8. Then again 2 1s are 2 and 2 2s are 4. And then 2 1s are 2, 2 1s are 2. Right, so 2 2s are 4, 4 2s are 8. 8 is the LCM of these two numbers. So I just need to ensure that this number must have 8 as the denominator. Right. So if I multiply 4 with 2, I'll get 8. So if I multiply 3 with 2, I'll get 8 as well. So 6 by 8. This number is equal to 6 by 8. So 6 by 8 versus 3 by 8, which is greater? So 6 by 8 is greater. So therefore, we'll say that 3 by 4 is greater than 3 by 8. Right. So this is the conventional way in which we can compare these two fractions. Now what is another way? You'll notice a pattern in this case. What pattern do you notice? Although they have different denominators, right? Since they have different denominators, they are unlike fractions. However, their numerators are same. So when we have such case, we don't have to compute the LCM and then convert them to like fraction. Right? So when two fractions have the same numerator, then we need to look at their denominators. So the number which has or the fraction which has smaller denominator is larger in such cases. And why does this happen? If you look at this figure, 3 by 4 means I am shading, or if I am just dividing something into 4 parts and I am shading 3 out of it. 3 by 8 means I am dividing something into 8 parts and I am shading 3 out of it. Right? So just imagine this scenario, you are having a pizza, right? You divide it into 4 slices, right? You have 3 of them. Another scenario wherein you have the same slice of same pizza, you divide it into 8 slices and then you are having 3 out of it. In which case you had more slice or more amount. So it is when you are dividing into 4 slices and then having 3, right? So that is why this rule works, right? So when you have two fractions that have the same numerator but different denominator, then compare their denominators. So the number that has or the fraction that has smaller denominator is larger. So this is opposite when we are dealing with like fractions. Right, so we'll see one more method in which you'll be able to solve it in a fraction of a second. Okay. So we have 2 by 3 and 3 by 5. Now this is a case wherein these two fractions are unlike fraction and at the same time their numerators are different as well. So all the two methods that we have studied so far is not going to work. So we have to convert them to a common denominator, both of them, right? So we have to convert them to like fractions. So that is why understanding how to convert unlike fractions to like is so important. So it will again help us in addition as well, right? So we have to find the LCM of 3 and 5. So since they have nothing in common, so I'll write 3 ones are 3 and then 3 5. So 5 ones are, so we'll just write 1 as it is and 5 ones are 5. So the LCM is 15. So I should have 15 here. If I multiply 3 with 5, I get 15. So I should multiply 2 with 5 as well. So I'll get 10. Similarly, I should have 15 here as well. If I multiply 5 with 3, I'll get 15. So I should multiply 3 with 3 as well. So I'll get 9 by 15. So among 10 by 15 and 9 by 15, 10 by 15 is greater. So we say that 2 by 3 is greater than 3 by 5. Right? So if you look at the figure, both of them look slightly similar. Right? So that is why, unlike fractions, until and unless you do the calculation, you'll not be able to say with a confirmation that which is greater. Okay. Now see, what was the other method that I was talking about? We are given two fractions, 2 by 3 and 3 by 5. Right? What we do, we just do cross multiplication. What does cross multiplication mean? This is the denominator of the first number, so we multiply it with the numerator of the other number. This is the denominator of the second number, so we multiply it with the numerator of the second number, first number, right? So what do we get? So if I multiply 2 with 5, I'll get 10. What do we get if I multiply 3 with 3? I'll get 9. So since 10 is greater than 9, 2 by 3 is greater than 3 by 5. Right, here we don't have to find the LCM and then compute equivalent fractions. Right, so this is very, very simple whenever we are given two unlike fractions. So it works in this case as well. So for example, what we'll do, we'll multiply 8 with 3. So we get 24 on the left hand side. For the right hand side, we multiply 4 with 3. So I'll get 12. So 24 is greater than 12. So that is why this is the answer. Right. So this is great. Let us solve some questions. So first of all, we'll see how do we find common denominators. Right. That we have already discussed when we are converting unlike fractions to like fractions. Right. So for example, we have to compare 2 by 3 and 3 by 5. Right. So what do? We find the LCM of the denominators, which is 3 and 5. Right. Again, we can use any method. We can use listing method. Right. We can use the factor tree method, or we can use the division or the cake ladder method. Right. So the LCM of 3 and 5 we had already calculated. It was 15, and then we wrote equivalent fraction. For one it was 10 by 15, the other it was 9 by 15. So since 10 by 15 is greater than 9 by 15, so 2 by 3, which is the equivalent fraction for 10 by 15, is greater than 3 by 5. Right? So what is the method that helps us to find the common denominator? It is the LCM. Okay, let us now solve some questions. So 5 by 6 and 11 by 12, which is larger? If we solve by the shortcut method, so we'll just do cross multiplication, right? So we'll multiply 12 with 5 and 6 with 11. So we multiply 12 with 5, we'll get 60. If we multiply 11 with 6, we'll get 66. Now among these two, we know 66 is greater, right? 66 is greater, so 11 by 12 is greater. What is another way in which we could have solved this? We had to first find the LCM of 6 and 12, so that we have two unlike fractions, we are converting them to like fractions. So 6 and 12, again 12 is completely divisible by 6, so their LCM is 12 and their HCF is 6. So their LCM is 12. Now I need to convert 5 by 6 into a fraction that has 12 as the denominator. So 6 times 2 is 12, so I'll multiply 5 with 2 as well, so I'll get 10. So 10 by 12 and 11 by 12, which is greater? 11 by 12 is greater. So we get the same answer, right? But this method, the second method that we are discussing, is the textbook method that we use. The first method that we discussed was the shortcut trick, right, that we can apply to exam. Another question, 10 by 14 and 6 by 21. So we'll do cross multiplication. 14 6 are 84, right? And then 21 tens are 210. Right, so this gives us 210, and this gives us 84, right? So 210 is greater than 84, so 10 by 14 is greater than 6 by 21. Right? You can also try to solve this using the other method that we discussed. So you have to find the common denominator and then the equivalent fractions. Next we have 15 by 40 or 2 by 8. Right? Again we'll multiply 15 8s are, we have 120. So we'll get 120 here. And 40 times 2 is 80. Now if we compare these two, we know 120 is greater than 80. So 15 by 40 is greater than 2 by 8. Once we know how to compare fractions, we can now move on to arranging fractions. So comparison of fractions was for cases wherein we had just two fractions. Arranging fractions means we have more than two fractions. For example, we are given 1 by 7, 2 by 7, 5 by 7, 6 by 7. It is just like comparing more than two fractions. So we can either arrange them in ascending order, which means smallest to largest, or descending order, which means largest to smallest. Here we are given four fractions, right? Since all of them are like, it is very easy to say which is larger and which is smaller. So 6 by 7 is the largest, then 5 by 7, then 2 by 7, and then 1 by 7. Right? So it is already arranged in ascending order. Right? So with like fractions, it is very easy. Now let us see how do we arrange unlike fractions. Right, so when we have more than two unlike fractions, then the cross multiplication method will not work. So cross multiplication method only works when we have to compare two fractions. It is not going to work when we have to compare three fractions. So when we have to compare three fractions, what we need to do, we need to convert these unlike fractions to like fractions first of all. And how do we convert them to like fractions? First of all, we need to find a common denominator. Right, and what helps us to find the common denominator? It is the LCM. So we need to find the LCM of 3, 4 and 6. We can either use the listing method, the factor tree method, or the division method using the cake and ladder method. So 3, 4, 6. Right, we'll start with 2. So 3 is not divisible, then we'll write 2 and then 3. Right, then I'll again write 2, then 3 and then 1 and then 3. Then we'll divide this with 3. So 3 ones are 3, 3 ones are 3. So 1 comes down and 3 ones are 3 again. Right, so LCM is 2 times 2 times 3, which is 3 2s are 6, 6 2s are 12. So 12 is the LCM. Now we'll try to make everyone's denominator 12. So 3, if I multiply with 4, I'll get 12. So I should multiply 2 with 4 as well. 4 I should multiply with 3, right, to get 12. So I should multiply 3 with 3 as well. So I'll get 9 by 12. 6 I should multiply with 2 to get 12, so I should multiply 5 with 2 as well. Right, so we'll get 10 by 12. Now once we have converted them to like fraction, now it is very easy to compare. We just compare the numerator. The numerator which is the largest is the largest fraction. The numerator which is the smallest is the smallest fraction. Right, so since 10 is the largest, then comes 9, then comes 8. So this represented 10, this represented 9, and this represented 8. So we have the same order, 5 by 6, 3 by 4 and 2 by 3. Right. So this is how we arrange fractions. Now there is again one more special case wherein they have the same numerator. So just like we discussed previously, when they are unlike fractions but they have a special case wherein their numerators are same, then we just compare their denominators. So the one that has the largest denominator is the smallest. So this is the smallest, right? Then comes this, and the one that has the smallest denominator is the largest. This is evident from the figure. This is 3 by 4, this is 3 by 5 and 3 by 6, right? So 3 by 4 is the largest, then comes 3 by 5 and then comes 3 by 6. Okay, I'm giving you a question. Try to solve this on your own and see if you are able to solve it quickly. So you have 4 by 5. So this is the first fraction. You have 3 by 10. You have 7 by 20. And then you have 1 by 4. You have to arrange this in descending order. Okay. Again, you have to follow the same process. You have to find the LCM and then you have to convert each of them to like fraction. Okay, in the next class, we'll start with addition and subtraction of fraction.